Awesome, thank you. So in this talk, I'm going to look at some of the features that we launched at Serenity World, which was about a month ago. This was the launch of our version 1, our first stable version of the product. And then diving into a few different ways that you can use some of those features that we might not have gone into at the conference. And then I'll be looking at some of the stuff we're working on at the moment and will be coming out over the next few months and into next year as well. So at the end, I've got room for questions, but if you want to ask questions at any time, then shout out, and otherwise you might forget your question. So SerilDB is a multi-model database for anybody who doesn't know exactly what it is. It's multi-model, but it's designed to sit in the center of a tech stack as a transactional database. It has a large amount of functionality, a large amount of features, and that's really designed to make the developer experience at kind of top level. So whether you're building a software as a service app, a gaming app, an application to the enterprise, for insurance, for biotech, for anything like that, so it really is designed to fit in and enable you to consolidate the databases that you perhaps use, or maybe sit on the side of your tech stack and allow you to query and work with your data in better ways than you currently are, and with reduced processes and reduced time with that as well. Some of the major features that we released at the conference last month were these 5 features here. So effectively, QL stands for our query language. This is an SQL-like query language that takes a lot of inspiration from MySQL or Postgres, so traditional SQL, but then goes beyond that, and it introduces graph concepts, time series concepts, and a completely different way of working with record IDs. So this is a record ID in SerilDB is effectively a way to get a specific record from the underlying database, whether that's in a particular table or a foreign table, or whether it's a range of tables. With SerilDB, you can do this in a really efficient way without having to use a single index. And so that opens up the possibilities of what you can do with the query language. And that's the one feature really that makes us different to every database out there and enables us to provide time series functionality and graph functionality, and then have the ability to go right from embedded to single node to scaling in a distributed cluster. Our second functionality, change feeds, is effectively change data capture. So for anybody who works in an enterprise context, that is the ability to listen to changes as they happen in the database. You're able to subscribe to any change on a table, whole tables or multiple tables, so an entire database, and you can listen to the changes as they happen. There's no layer sitting in front of that, so it's effectively a complete raw feed of the data as it changes. And this has benefits for enterprise uses, whether you're building some kind of listening logic in front of the database, and it has other benefits internally that we will be building on going forward over the next few months. Indexing, it's a feature, it's also kind of not a feature. It's a feature that every database should have. In SerilDB, indexing is a core part of our database engine. We don't use any third-party library, Lucene, Tantivy, or any of these other packages to provide our indexing. So we built everything ourselves in Rust, and that's one of the benefits of choosing that language to do that. It also enables us to support indexing across the SerilQL language, as opposed to having to push that out to a separate language. So I'll come on to that a little bit later. Live queries, so LQ, is the ability, how do I summarize this? It's effectively change feeds, but you have a distinct view of each data depending on the user that you are as you query the database. So I'll come on to the difference between change feeds and live queries a little bit later. And then ML, as Maxwell talked about, is about bringing machine learning models into the database. So live queries. So the difference between change feeds, which is where you have a complete view of any change to a table or to an entire database in a traditional database. In SerilDB, live queries enable you to listen to any change to a record or to a table, but based around the authentication that you have when you access the data. So effectively every single stream, if you have 100 people listening to changes in a table, every single one of those 100 live queries is unique to the user viewing it. So instead of being able to go back in time and get changes from a previous point in history or in time, you can only view changes as they happen. And you can disconnect and you can reconnect and you can resubscribe, but you don't have the ability to go back in time. So that is a limitation of live queries because of the way we've implemented it, which has the benefit that you can effectively have a unique view just for that user and just for the records that they can see. The one interesting fact is because of that layering of the authentication right into the live queries, you can either connect traditionally to the database from a back end. So if you're building a business logic layer that sits in front of the database on the back end, and you're listening to, maybe you have your users authenticating in a particular way, and then you have your logic listening to those queries yourself, then you can do that. But the one benefit is you can actually connect directly from a browser. So you can connect directly from the database from Google Chrome, from Safari, authenticate in the way that you choose as a developer, so the way that you build that into your application, but then receive live streams right down to the device. So I'll give some brief examples here, but really the true power of live queries comes when you merge this query functionality with some of the other features that we're going to briefly go over today before I touch on the future things we're working on. So effectively, a select query can now be completely made live and responsive by just adding the word live in front of it. There are a few limitations. You can't do aggregation, data aggregation. Effectively, we are reading records as they change and pushing updates directly down to users. But the live query enables you to work with filters, multiple filters, and with that permissions logic. You can then combine these live queries with other functionalities. So in SerilDB, we have a feature which is effectively aggregation of data, so predefined aggregation of data up front. So if you have a dashboard, and you know that on your dashboard you always want to get the total number of sales by month over the last year. So effectively you have 12 months, but let's say there are 1 million sales this month or 1 million temperature recordings. That's a lot of data that you have to go just to produce that chart for that dashboard. But you know that you need that chart up front. You know that the top left part of your dashboard always has that chart in it. So instead of computing that every single time that dashboard's loaded, you can actually define that query as a view. Effectively what a view is in an index. We use a single write when data is updated in the database, and it actually updates that view with the correct data. So it enables you to do aggregation or filtering, sharding. As you wish, you can do this views of your data. But then you can benefit from live queries on those views as they change. So that gives you the ability to do live updating dashboards with effectively 2 queries. So this, if you have 6 charts on your dashboard at the start of your app, let's say, you would have 3 to 6 tables defined as a view. You would have a live query that listens over those different tables. And effectively, you've now got a real-time updating, really performant and dashboard with just effectively 12 lines of 12 queries themselves. And you don't have a business logic layer in front of that. You can connect directly to the database from the browser. So, as I said, indexing is a core feature that we released. We have support now for traditional indexes, full-text search, and vector embeddings. So if you're using a database like Elasticsearch, if you're using a database like Pinecone or Quadrant, or if you're just using a traditional database like Postgres, all of that functionality we now have built into SerilDB, and we're improving the performance as we go along. Importantly, though, where you can benefit from Seril is because we can store structured and unstructured data in SerilDB. Instead of just benefiting from just an index on a single field, you can actually go kind of several steps further. And you can do compound indexes on multiple values which are nested in arrays of data or unstructured object data. So if you're working with unstructured log data, if you're working with arrays of scores or tags or values or email addresses or anything like that, you're able to then, instead of having to push those out into separate records in separate tables, which you might have to do in other databases, you're able to bring those all into that single record. Perhaps that's where they sit best, but then index on that data either individually or in a compound way. So it's unique, and I'm not sure of any other database that does it this way or enables you to do it this way, but I'd love to be corrected if there is one. Then you can go a step further and say, we actually want to utilize these indexes in a full text search way, but benefit from effectively what you can do on Google. So being able to add weights to results and actually having more of an understanding of your data. So this index here enables you to search for any book which contains the title Rust Web or author Maxwell Fitton, but it's actually going to search within the text, and it's not necessarily going to search for those two words together. It might search for typos, it might search for things that look similar to the data you've entered, and then it will give you results based on weighting rather than results based on any other order. Finally, vector embedding indexing. If any of you have used or heard about the wave of new database types, which is specializing in vector embeddings, this effectively enables you to improve the way that you build machine learning or AI-based applications. So if you connect to OpenAI and you use their API you push some text in, and the API gives you back what's called a vector embedding, which is effectively an array of 1,536 floating point numbers, so decimal numbers. You then have to store those and efficiently search for them in your application if you want to do anything around AI or ML. With SerilDB, you can now put those embeddings right into your records and index them and that data. So this enables you to not have to use a specialist database running on your cluster on the side of SerilDB in order to do that. Now, machine learning is kind of one of the really exciting features that we've announced at SerilDB World and is coming in version 1.1. But in a way, it's invisible to the user. The way we've implemented it is so simple that it really doesn't seem like a feature at all. So we've launched SerilML, which is, as Maxwell said in his talk, a new file format and a new package in Python that enables you to do your machine learning logic as you normally do in Python, but with the knowledge that you might want to run that SerilML or that model file somewhere else, maybe in Python or maybe on SerilDB. You can package that into a file format. Under the hood, the model file is untouched. We don't look at data, we don't inspect your data, we don't understand that model in any way. We just add some metadata and some logic, which means that we can then run that model in the database in any way that you as a developer choose to. So where this gets really interesting is when imported into SerilDB, that model, which is, let's call it insurance prediction model, actually just becomes a function. And in a similar way to how you might have used stored procedures in Postgres or MySQL or any other database, that model is now a versioned procedure which takes data, the right data that it expects, and gives you a result. That result could be a true or false, a percentage, likelihood, or it could be a categorization, or anything else. It could be text, whatever that model returns as a value. Now, the models can take either raw input, as you can see here, and they can also take structured input. So here, with SerilML, we've defined that this model accepts certain arguments, and with those arguments in the SerilML file, they get converted into raw inputs. So in this short example here, what I'm saying is this function, I want to run an insurance prediction inference every single time, or for every single record that I'm selecting. Now, I'm only selecting from a single record here, person Toby. But effectively, what this is going to do, it's going to run that model, it's going to push in the age field, it's going to push in the rounded value of my income, it's going to push in any connected graph queries, so it's going to look at any properties that I have purchased. If I have, that will give a true or a false. And then the result in that query, the likely to buy field, will be the result of that model. Now this is basic, right? This is really simple. But then you can get to some really interesting and cool stuff, because effectively that model is just a function, and that's one of the best pieces of it. It seems so simple, but that simplicity brings such advanced functionality. So here we're defining an event. So an event is effectively anything, whenever something changes in the data, you can define an event that happens when that behavior happens, when that event is triggered. So this event specifically is going to be triggered on any user. So whenever a user record is created, updated, deleted, this event will run. Now our when clause limits the behavior of this event and says only when the income of a user is not the same as before. So if they're newly created, the income will not be the same as before, because before it didn't exist, so it will be triggered. If the user's income is increased or decreased, then this event will trigger as well. What this then does is actually sets the likely to buy field on that user record where the income is updated. And it runs that insurance model, that prediction model, with the fields from that record. And then instead of being run whenever you're querying the data or the database, it runs just once when that income is changed. So this is just a simple example of how you can use this functionality or this ML functionality alongside other features in the database. Another example here is the ability to, I literally just wrote this 5 minutes ago, but the ability to run sentiment analysis. Let's say you've got a model you pulled from Hugging Face, it understands text, so you push text into it, and it analyzes the sentiment of that model and gives you a percentage. So here we're defining an event. Whenever a chat message is created, and it's created by a user as opposed to by an employee, let's say, then I want to update that record, and I want to set the sentiment value to positive or negative or 55% or 75%, whatever the model returns. So this now enables you to have automatic sentiment analysis based on any message as it is changed or as it is created in the database, simply with a function. You can then go a step further and you can say, I've got a new model which actually generates responses. It accepts as an input the message. Let's say a user has messaged, and I don't want to write message at all. I want it to create a chatbot. So you can now, whenever a response is made, you also create a response where you take that message content, you push it into the model, and then you can create a response back. Now, where this gets really interesting is then you can add live queries to that functionality, and you can say, I want somebody to listen, so I want to select all records or all new response queries that I'm allowed to look at. So now you can build a real-time chatbot with just 6 queries based around ML, but completely custom tuned to you and your organization using models that you have trained or you have complete control over without pushing that up to a separate platform. So that's really, what we think, that's a really cool feature. So that was kind of a brief overview of Cerulean 1.0, but what lies beyond, and this is a question we get asked a lot, because we've been going almost a year now, or just over a year. We're a new database, and you compare us to others out there. There's a lot of databases out there, and they've been going a lot longer than us. But we're working on some really cool stuff, and I'll go into some of that stuff now. So with live queries, currently that works in a single node environment. But over the next few months, we'll be pushing support for notifications across a distributed cluster. So CeruleDB works in an embedded mode, so if you're running in Python or Node.js or Dino or Rust, and you can also run it as a single node server, which is the typical way that people run databases out there. But you can also scale this up. You can run this on 10, 20, 30 nodes with support for petabytes of data if that's what you want to do, that's what you need to do. So our live query functionality in a distributed setting will enable you to scale up, to have that highly available, highly scalable runtime, and to support live queries across that cluster. In addition to that, we've got some improvements coming around garbage collection. So when you start nodes up in a distributed cluster, clearing out the data from nodes that have died or have crashed. Not that it happens, but just cleaning up data that shouldn't be there any longer. Indexing is a big one. Obviously, performance of our indexes is key. Any application out there relies on indexes, and So the performance of our full text search and our vector embedding indexing is absolutely paramount. We're improving full text search as we go along, and our vector embedding indexes, which were released in beta just this year, we'll be introducing and improving the performance of those as well. In addition to that, in the SerilQL language, we're going to be adding support for additional operators and additional keywords. So at the moment, we support the and greater than, and we've got a PR coming soon for contains and contains all. So there's more and more support coming every day for more operators, more keywords. And I think importantly, there are many more keywords in SerilDB than a lot of databases out there. For instance, you can search for any item in a table where an array field, an array of values, contains all values, or contains any value, or contains none. So very flexible, but it also means it's harder for our indexes to support that functionality. The other thing is a lot of the vector embedding databases out there, so Pinecone, Quadrant, Weaviate, they typically support HNSW, so approximate nearest neighbor retrieval. At the moment, our vector embedding indexing supports exact nearest neighbor retrieval, so it's more accurate, but it's less performant. We'll be introducing HNSW, so approximate nearest neighbor retrieval, in due course as well, and then you'll be able to choose as a developer whether you want to use exact search or approximate search. Query languages is as a big one. So actually, this is an interesting topic. So SerilDB was actually written in Golang. I was a big fan of Golang until about 2 years ago when I decided to completely rewrite the entire database into Rust. And to be honest, Maxwell's talk shows exactly why you want to do that. Rust is a brilliant language to work in. I don't think there's too much of a learning curve to it. I guess once you've gone over the learning curve, then you forget about it maybe. But looking back, and it was a big decision at the time. Do we spend a year rewriting this entire 30,000 line code base from Golang into Rust? But looking back, that was probably the best decision we made. However, having said that, we had an engineer join us, and he looked at the query parser, and he was like, I want to rewrite this. So the entire query parser is being rewritten, and should be in beta at least, I think, before the end of the year. But we'll be testing that out. But that's going to give us much better improvements to speed and performance of the parsing. Much better memory usage, and importantly, and this is where it becomes really interesting, the ability to reason about the query language. So at the moment, SerilQL is really flexible. You can, if you look at other databases, you have the concept of keywords. So where, for instance, or and, or, they're specific keywords. In SerilDB, there are no keywords. A keyword is only a keyword if it's expected at that position in the query. So because of that, you get incredible flexibility. But a downside to that is it's very hard to reason about, because you can select all from an and table, or a where table, or a from table. So you could, so we've select star from, yes, is a good one. So it's very hard to reason about that. Now, we always want to keep that flexibility, because as a graph database, how you model, if you look at a relational database, you'll model data in terms of people and users and orders. In SerilDB, the way that you define your data is around person, or user, or order. And there you see order, order by. And that's where you've got the issue. The reason we do that is because if you want to select a specific record, which is something you can do in SerilDB, but you can't do elsewhere, and it's how the graph queries work as well, you select all from person 1, or person Toby, or you might relate from person Toby to person Maxwell. Because of that, you wouldn't ever relate from people Toby to people Maxwell. So having this singular table name means that often the keywords can collide with tables. So orders becomes order, and now you have to then always treat that as a keyword. So we want to keep that flexibility, but we also want to enable SerilQL to work well with IDEs and other programming languages or language servers where it gives the developers the ability to reason about how their code is performing. And then we've got a chunk streaming parser, so it's effectively the ability to run single statements line by line, as opposed to storing them all up in memory and running them in one go. Now on the machine learning side, we've got some really exciting stuff coming for 1.1. When we initially released it, we thought we were only going to be able to support up to two gigabyte files, which effectively limits you from doing any large language model support. But we're going to have support for multi-gigabyte files. We're going to support streaming those models into SerilDB, so it's really efficient, really quick, streaming into SerilDB, and then streaming that behind the scenes to storage, and I'll come on to that in a bit. And then as you run that query, which maybe makes use of an ML model, that will chunk that download from wherever you're storing that model, and it will then cache it on the device. So we'll have support for PyTorch, sklearn, and TensorFlow models. So effectively, pretty much every model out there, you could be able to pull a model from Hugging Face, push it into Python, run your normalization logic, or build your normalization logic around it, and push it right into SerilDB. And then, in order to make this work at scale on a single node with large model files or in a distributed environment as well, we're going to be supporting local storage, so on the machine that the database is running, if you're running in a single node, or the ability to store it in Google Cloud Storage or S3 or Azure Storage as well. That will mean that you can run multiple SerilDB nodes. You can run 10, 20, 30 SerilDB nodes as you need to do the inference that you need. And those models will be cached on the device as they're needed, so there are reduced start times after the initial download. So some really exciting stuff coming for SerilML. Finally, this brings me on to like the general stuff that doesn't fit under those features themselves. So we are continuously working on the performance of the database. As I said before, we're rewriting our query language. We're improving the way that aggregate queries are run and performed. They currently use more memory than we need to. We're going to be improving the performance of subqueries and graph relation queries. And then caching. Interesting at the moment, SerilDB has some incredible speed, and we'll be coming on to benchmarks in a bit, but we have no caching in the database whatsoever. A lot of other databases out there, they absolutely rely on caching to make their databases quick and performant. SerilDB hasn't even built that layer yet. We haven't even got to building caching, and we've already got the performance that we're seeing. So really exciting times, but caching is definitely something we'll be adding in over the next few months, if not going forward over years as well. So that's going to have some great impact on the database. We'll also be adding in GraphQL support natively into the database. This will enable any user who has built workflows or pipelines or business layers in front of GraphQL layers. You'll be able to port that directly to SerilDB and benefit from the actual graph-like data structure that you see in SerilDB, rather than sitting on a relational database. Database administration interface is coming, and then benchmarks and comparisons. We've been working on these internally. Some really exciting stuff. We're not going to be showing them just yet, but they're coming soon, and definitely look out for those. We've got some exciting stuff. And then security. We've got some improvements coming to that area as well, and some big announcements in the future, but some really exciting stuff. So, literally ask me anything. It can be about my talk, it can be about anything in SerilDB that you don't understand or anything at all.
I'm just going to hop in here and say, for our online community, if we can chuck the catch box so that they can hear as well. Thank you.
Hello. You said SerilDB have a built-in authentication functionality, right? And also you said it can directly connect from the browser. So what do you mean? It can, like SerilDB has a built-in REST API functionality, right?
Yeah, so you connect to SerilDB over multiple ways, actually. HTTP, if you want to. That's not really the recommended way, and it's not the way that our drivers ideally would connect. Then you can connect over WebSocket, and we've got support for other protocols coming soon. But yeah, effectively WebSocket and HTTP, and on both of those connections, there's a binary protocol and there's a text-based JSON protocol. So absolutely, you can connect to this directly from Chrome or from Node.js, Deno, WebAssembly, Golang, Python, whatever it is.
Okay, so my question is, if I want to build a functionality like authentication providers, like Google Auth and Meta Auth or Apple Auth or any other providers, how I can build with SerilDB?
Yeah, so let's see. Okay, that didn't work. we've got some improvements to the authentication flow. So we want to actually have native support for OAuth and flows like that, and that's that last point on that slide. But at the moment, you can effectively do that with a very small microservice or a function as a service that effectively makes one SQL call, and then you can build completely passwordless authentication flows with GitHub, Microsoft, Apple, Google, whatever it is, Facebook login as well. So yeah, that can be done. It can't be done right in the database just yet, but the database has support for JWT, so tokens and everything like that built in as well. So you can do password-based authentication right in SurrealDB, and you can do passwordless. Actually, you know what? I think someone on our GitHub actually had a whole GitHub auth flow right inside SurrealQL. It's probably not advisable, and we do have plans to improve that, but it can be done already.
Thank you very much.
Hey, I was taking notes while you were presenting. So I do have a few random questions on different topics. I'll start from the last one. You said, like, I'm still confused where the data actually lives, because you were saying that you can run, like, you can embed it, you can run it from the browser, or in a single node, or multiple web. So, cool, where the data lives. Like, can we dump all the data into either S3 or GCP or locally, and then it just runs on top of it, like DuckDB, I think it is?
Yeah. So SurrealDB, the way we built it is effectively it's a storage layer and then a compute layer. So SurrealDB is the compute layer. And something I didn't talk about today is something we're working on, which is called SurrealKV. So SurrealKV is a replacement for RocksDB, if you know RocksDB, which is built by Facebook. And it'll also be a distributed version in the future, which will enable us to completely run it that way as well. But at the moment, we use FoundationDB in a distributed setting, or you can run on TiKV as well. Mm-hmm. And in a single node, you can choose RocksDB or SpeedDB. So you choose as a user where you want to store your data. Now, we've thought about, there are ways, and you look at some databases out there that do this in a roundabout way, but you could store some of that data onto S3. It's hard to make that performant. And if you look at the databases doing that, that's the biggest struggle, I guess, making that performant, because you've got the cold start time. Ultimately, our storage layer that we build on has to support transactions. So it has to be an ordered key value store, and you could do that in S3, but it has to support transactions as well. So it's going to be, there are ways of making it work, and if you look at a database called, is it Redis Set? It's built by no, Rockset, sorry, Rockset. Yeah, Rockset does actually enables you to store unstructured data in S3 and then query it. Effectively, RocksDB has been altered so that it's storing in S3 and then caching locally as well. There are ways of doing that, but you've always got to think about performance. It depends on the amount of data or what data you're querying. So that model works really well for log data that you might do analysis on, but it doesn't really matter if that query takes 5 seconds or 100 milliseconds. With this type of database, it matters. If your query takes 5 seconds, that's too slow. It matters like how fast your query runs. So effectively in a single node, we run on RocksDB, which stores the data locally, and in a distributed node or distributed setup, you run it on top of FoundationDB. That enables you to scale out. So FoundationDB is Apple, is now owned by Apple, and scales effectively. If anybody in here knows or has heard of iCloud, then you use FoundationDB.
Cool. I don't know someone else, but I do have a few other questions.
I think we've got time for one more, so absolutely do dive in, unless we've got some online questions as well. Do we want to do that one?
Cool.
Well, let's go with you. Yeah.
Okay. You were mentioning about there are like some limitations on the queries, on the live queries, that you cannot do aggregations, and if you want to do aggregation, you have to create a table and stuff. Does SurrealDB support window functions as well for doing that kind of live queries?
We don't support window functions yet, only because we haven't got there. But interestingly, I saw a question on our Discord today where someone had a window function or a query about how could you rewrite this window function, and it can already be done, apparently, using nested subqueries. So we definitely want to improve that. there are always going to be limitations on what you can do in a live query, only because of the way that live queries work. Effectively, live queries is it's storing a piece of data on the key value store, and it's saying whenever these records of this type are updated, then do something. It doesn't ever do that in an aggregate way, because the aggregation happens after that step. So the limitation is always going to be there on aggregation or windowing or stuff like that, but you can do windowing functions in a roundabout way right now, and you could push those into live views. And also, a view can also rely on another view. So you could build a view that relies on another view, which relies on another view, and you can have these kind of compound views.
And then do all the triggers by events?
And you can trigger all of those as well, yeah.
Okay, interesting. Hard to maintain, I guess.
I mean, at the end of the day, it's just a single SQL query, right? So it's, as a developer, it's definitely going to be easy. You're not, this isn't when the word view is used in other databases, there's often a difference in meanings. Some are materialized and some are run when you query it. But yeah, it's designed to be performant. And it's designed because this is a document database, right? Mm-hmm. We're not storing records in a relational table where it's just, let's say, 4 columns. We actually store the data, the field data, the metadata with each record, similar to how MongoDB does it. Because of that, we have to work out ways of doing aggregation more performantly than you would do in another database of our type, in order to get to the performance of something like Postgres. Where we benefit is you benefit from the relationships. So as you go and use graph data and connected data, then you can benefit from that as well. And then when you're working with unstructured data, that's where SerilDB shines. So using those different types of data together, and then in order to make that work performantly in a traditional way, that's where the views come in.
Cool. Thank you.
Amazing. I'm going to wrap it up there and say thank you so much, Toby. That was really fantastic. Round of applause.